Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Siti Nur Hashimah binti Muhammad Razali and my matrix number is AE190046. So today I will present activity 2, open loop speed control system, to observe the input voltage and tachometer voltage for different motor speed. Okay, so for activity 2, first, we need to repeat step 4 in activity 1 by setting the input speed to 2500 RPM and then record the input voltage. Okay, so this is the simulation. If we want to observe the input voltage, we need to run and click here the input voltage component. Okay, so the input voltage is 162.5 volt. Okay, next, repeat step 1 in activity 1 and set the input voltage to the value obtained in step 1 activity 2. Then set the brake to 0. Run the simulation and record the motor speed at t equals to 10 seconds in the table given. Okay, so this is the simulation. We already set the input voltage based on the last step. Okay, then we need to observe the motor speed. So we run, and to observe the motor speed, we need to click the motor speed component. Okay, so at t equal to 10 seconds, this is the motor speed. So okay, as you can see here, the value of motor speed is 7.249 to the time to the power of 3, which means the RPM is the motor speed is 7,249 RPM. Okay. Okay, so then next we need to change the brake scale to the given brake scale based on the table, and we need to repeat the same steps. And last, we need to plot the graph of motor speeds against brake scales from the last activity. So we need to obtain the data to the Excel, and then we just plot the graph. So this is the graph of motor speeds against brake scale. As you can see, the motor speeds is inversely proportional to brake scale, which means when the motor speeds increase, then the brake scale will decrease. So that's all from me. Thank you.
Assalamualaikum. My name is Sharfana Afrina binti Said Yusof and my matric number is DA190146. In this video, I will do simulation for activity 3. So this is the plot diagram for the closed loop control system. Our input voltage here is 162.5 volt. Our proportional gain here we set to 200 for the saturation block, the upper limit is 240 volt and the lower limit is 0. And this is the electrical part. The numerator is the EMF constant and the denominator is the armature resistance and also armature inductance and armature resistance. And then here is the mechanical part. So the denominator for the mechanical part is the moment of inertia of motor and also the viscous frictional constant of motor. And this is the brake where we will control the brake in order to see the speed output. So this is the scope where we will analyze the speed when we control the brake. This is the torque constant and tachometer constant. Torque constant and tachometer constant we get from the given parameter value. Okay, for the simulation time we set to 12. So now let's run the simulation and see our output speed when the brake is 0. So from here we can see that our speed when the brake is 0 is 2488 rpm. Now let's change the brake to 3 and run again the simulation, and now we can see the graph. So when the brake is 3, the motor speed we get is 2487 rpm. Now change the brake to 6 and we get the motor speed is 2485 rpm. Change again the brake to 9 and we get the motor speed is 2484 rpm. Now I'll change the brake to 12 and let's see our motor speed. So our motor speed is 2483 rpm. Now change the brake to 15 and we get our motor speed is 2482 rpm. And then I will brake to 18, change our brake to 18 and we will get our motor speed is 2304 rpm. And lastly change brake to 21 and we will get our motor speed is 2073 rpm. So from the simulation we could see that when the brake is 0 there is overshoot in the graph, but when the brake is 21 we can see that the graph is a lot more smoother and there is no overshoot. Now let me show the graph for when brake is 0. So you can see here that there is a small overshoot in the graph. So we can conclude that when the brake is higher, when the brake is getting higher or bigger, the motor speed will be reduced. So I think that's all from me. Thank you.